Good morning, students. Chapter 6, Work, Energy and Power. Yes, again today we will see some questions. See here. A 1 kg block situated on a rough inclined plane is connected to a spring constant 100 Newton per meter. The block is released from rest with the spring in unstretched position. The block moves 10 cm down the inclined plane before coming to rest. Find what is coefficient of friction between block and this surface. See what is question. Yes, it is one inclined surface at angle 37 degree. One block is connected to a spring. Initially, this block is at rest and this spring is unstretched. This spring is unstretched. Now, if this block is released, obviously this block will move in downward direction, and due to that, this spring is stretched. Due to this spring is stretched. Okay? But after traveling a distance of 10 cm on this inclined plane, this block comes to rest. Then yes, you have to find what is coefficient of friction between block and surface. Okay, now how to find this question? How to solve this question? See, first of all, we will write the data. Here it is. A 1 kg block means M is equal to 1 kg. On a rough incline, is connected to a spring of T is equal to, it is 100 Newton per meter. The block is released from rest with spring in unstretched position. The block moves 10 cm down, so that x is equal to, it is 10 centimeter is equal to, here it is 0.1 meter. Down the inclined plane before coming to rest, find mu is equal to what? Coming to rest means what happens? See here. First of all, I will find numbers of forces acting on this block. First force, that is, yes, mg. It is always acting in vertically downward direction. Yes or no? Mg is always acting in vertically downward direction. Mg is always acting in vertically downward direction. Clear about this? Okay. Now we will take two components of this mg. One normal to surface, one parallel to surface. And here it is normal force. And here it is neutral force. Clear about this? Yes, we know that this angle will become 37 degree. So it is called mg cos 37 and it is called mg sin 37. As this block is moving in downward direction, friction force is in opposite direction. So it is friction force. And yes, you are given okay, this spring is having light, okay, is having negligible mass. Clear about this? So yes, what happens? See, yes, it is one inclined plane, one block which is connected to this spring, okay. So yes, now we have to find what is coefficient of friction between this. Now see, initially this spring is unstretched, so no potential energy is stored in it. Now when the block is moving, this spring is stretched. So there is some potential energy stored in this. Yes or no? This block is displaced, means work is done on block, and due to that, this spring is in now stretch condition. So as block is moving in downward direction, work is done on block. And due to that, this spring becomes in stretch condition. So we can say, due to work done on block, this spring is in stretch condition. So due to this work done, there is some potential energy in this spring. So according to law of conservation of energy, we can say a work done on block during displacement x is equal to energy stored in spring. Okay, as this block is moving in downward direction, performing some displacement, means some work is done. Due to that, this spring is stretched. So yes, we can say work done. Here I have to write work done by block during displacement x is equal to energy stored in spring, due to displacement of block, Clear about this? So yes, work done by block during displacement. Work done. So now first of all you have to find work done. What is work done on this block? Work done means force into displacement. Block is displaced by distance d. Then we have to find what is resultant force parallel to slope. So see here, first of all we have to find what is resultant force parallel to slope. Resultant force acting on block parallel to slope. That is sigma F is equal. Resultant force. Okay, sigma F is equal. Yes. Downward to slope it is mg sin 37 and upward direction it is friction force. So here it is mg sin 37 minus here it is F. Yes, we have to neglect tension produced in this wire which is spring. Okay, so sigma F is equal to mg sin 37 minus F. Sigma F is equal to mg sin 37 which is acting in downward direction and friction force which is acting in upward direction. So yes, sigma F is equal to this mg sin 37 minus F. Mg sin 37 minus F. Clear about this? Okay. Now sigma F is equal to mg sin 37. F means we know that F means it is mu into n. And therefore sigma F is equal to mg sin 37 minus what is value of n? Yes, n is equal to mg cos 37. N is equal to mg cos 37. N is equal to mg cos 37. So yes, if I am taking mg common, then it is mg sin 37 minus mu cos 37. Clear about this? So yes, resultant force acting on block parallel to slope. Sigma F is equal to mg sin 37 minus F. Mg sin 37 in downward direction, F in upward direction. Okay, and yes, mg sin 37 minus F is equal to mu into n. Block is not moving in this plane. Yes or no? So yes, block is not moving in this direction. So n is equal to it is mg cos 37. Okay, so what is resultant force acting on block? So yes, it is sigma F. So how to write equation of work done? Work done by block during displacement x. It is work done by block. Work done means it is sigma F into x. Sigma F into x is equal to energy stored in spring. It is half kx square. Clear about this? So yes, sigma F. What is value of sigma F? Here it is. It is mg sin 37 minus mu cos 37 into x is equal to it is half kx square. Clear about this? So now we have to put values. See how to put value. Here it is. M. What is value of M? Mass it is given 1. G 9.8. X. What is value of X displacement? It is 0.1. Clear about this? Now in bracket sin 37. Sin 37 its value is 0.6. Okay, mu as it is we have to find cos 37. Cos 37 its value is 0.8. Its value is 0.8. Left hand side clear? Okay, right hand side is equal to half. What is value of K? That is spring constant. Yes, it is 100. It is 100. And X. here it is 0.1 whole square. Here it is 0.1 whole square. Clear about this? Okay, so now how to find this? Now how to find this? See, here it is. First of all, left hand side. 1 into 9.8 into 0.1. So it is obviously 0.98. It is 0.98. So yes, here it is 0.98. In bracket, it is 0.6 minus 0.8 mu. Clear about this? 9.8 into 0.1, it is 0.98. 0.6 as it is minus 0.8 mu as it is. Now right hand side, half into 100 into 0.1 square. 0.1 square means 1 upon 100. So 1 upon 100 and 100 cut, and 1 by 2 it will become 0.5. It will become 0.5. Okay, so yes, 0.6 minus 0.8 mu is equal to 0.5 divided by, it is 0.98. So therefore 0.6 minus 0.8 mu is equal to, it is 0.510. It is 0.510. Okay, so therefore if I am taking this term this side, then it is 0.6 minus 0.510 is equal to 0.8 mu. Okay, 0.6 minus 0.510, it is nearly 0.09 is equal to 0.8 mu. So therefore mu is equal to, it is 0.09 divided by 0.8. So therefore mu is equal to, it is 0.112. It is your answer. Okay. So again, you have to draw this block diagram. Okay, the numbers of forces acting on block, mg cos 37, mg sin 37, friction forces acting in upward direction. What is condition? This block is moving in downward direction. Displacement means work is done on block, and due to that work, this spring is in stretch condition. So simple, work done due to work done on block, spring is in stretch condition, so energy is stored in it. Simple, work done by block during displacement x is equal to energy stored in spring due to displacement of block. That work done is stored as energy. What is equation of work done? Force into displacement. So first of all, we have to find this resultant force acting on block. Draw diagram, and then you have to find resultant force, and then calculate it. Clear about this? So yes, again it is one question which is based on law of conservation of energy. Now next question is, see, the bob of pendulum is released from horizontal position. If the length of the pendulum is 1.5 meter, what is the speed with which the bob arrives at the lowermost point, given that it dissipated 5% of its initial energy against air resistance? See here. It is pendulum. Okay, if see, these are positions of pendulum. Okay, it is called its mean position or normal position Okay, and it is lowermost position, lowermost point, it is uppermost point. If I am taking reference surface from this point, then yes, at this lowermost point, potential energy U is equal to 0, but kinetic energy is maximum. We know that when object is moving in upward direction, its speed decreases to this uppermost point. Uppermost point means its maximum position. Then at this position, its potential energy will become maximum, while its kinetic energy will become 0. Simple. So for pendulum, you have to remember these points. Okay. If this point is called lowermost point. It is called lowermost point, or we can say mean position, or we can say mean position. Okay. This point, it is called uppermost point. Okay. Or it is called extreme point, or it is called extreme point. Okay. So yes, for pendulum you have to remember these situations. Again, it is easy to understand. Okay, it is easy to understand. At this point, as object is on reference surface, its potential energy is 0. At this point, it is always in motion. Okay, so its kinetic energy is maximum because potential energy is 0. At this point, that is uppermost point, speed is 0, then kinetic energy is 0, then potential energy is maximum. Simple. Because K is equal to half mv square and U is equal to it is mgh. U is equal to it is mgh. Now what is given? The bob of pendulum is released from horizontal position if the length of the pendulum is 1.5 meter. If length of pendulum is 1.5 meter. Okay, what is the speed with which the bob arrives at the lowermost position? See, like this. If it is point, it is bob, it is length. If this, see, the bob of pendulum is released from horizontal position. If it is released from horizontal position, then obviously, okay, it will move like this. It is its initial position and it is its final position. Okay, so what is the speed with which the bob arrives at the lowermost point? Here, at this point, what is its speed? Then see, initially bob is in this situation. I am taking again reference axis passing from this lowermost point, reference surface passing from this lowermost point. So at this point potential energy is 0, but kinetic energy is maximum. Yes or no? Yes. At this point, as it is in horizontal direction, in rest condition, it is released. Means here it has only potential energy. Here it has only potential energy. Here it has only kinetic energy. Okay. If air resistance is neglected, we can say its total potential energy is converted in total kinetic energy. But here you are given, okay, given that it dissipated 5% of initial energy against air resistance. At this point, it has potential energy. 5% is used. 5% is used. Okay. Then when it reaches to this point, that is lowermost point, it has only 95% of its initial energy. 95% of its initial energy. Yes or no? Yes, it is. Why? Because 5% is used. 5% is used. So here at this point, kinetic energy is due to kinetic energy, that is half mv square, is equal to due to 95% of its potential energy, that is mgl. Why mgl? Its height is initially, that is length of pendulum. Okay, so half mv square is equal to 95% of mgl. Again, why 95%? Not 100. 5% of its initial energy is used against air resistance. So yes, due to remaining potential energy, it will achieve some kinetic energy. So half mv square is equal to 95% of mgl. So yes, here how to write? Here it is half mv square, 95 divided by 100, and here it is mgl, m cut. Yes or no? Now you have to find v and make this v square as subject. V square is equal to, it is 95 into 2 into gl divided by, it is 100. Yes, you have to calculate what is value of v square, find value of v, and you have to write your answer in comment box. Yes, you have to learn how to find square root. Okay, that's why this question is in homework. Okay, if you have any doubt, then contact me. But you have to try how to find square root. You have to find how to find square root. Clear about this? So yes, it is one simple question. It is one simple question. But first of all, you have to understand this. What is uppermost point, lowermost point, at which point, which energy is zero and which energy is maximum. Clear about this? Now next question. The pump on ground floor of building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meter above the ground and the efficiency of pump is 30%, how much electric power is consumed by pump? See here, a pump on the ground, a pump on the ground, a pump on the ground, okay, of a building can pump water to fill a tank of volume tank, here it is tank, here it is tank, at height h. Okay, so yes, first of all we will write data. See here how to write data. A pump on the ground or floor of building can pump up water to fill a tank of volume. This tank, its volume V is equal to, it is 30 meter cube. Yes, in tank we have to fill water. So what is density of water? Density of water, rho is equal to, it is 10 raised to 3 kg per meter cube. Density of water, it is 10 raised to 3 kg per meter cube. If this tank is completely filled, then what is mass of water? Mass is equal to, it is rho into d. Just you know what is definition of density. Density is equal to mass upon volume. So mass is equal to density into volume. So it is 30 into 10 raised to 3 kg. 10 raised to 3 kg. Clear about this? Next data. If a pump on ground floor of building can pump up water to fill a tank of volume 30 meter cube in 15 minutes, T is equal to 15 minutes. So yes is equal to is 15 into 60 seconds. Okay. If the tank is 40 meter above means H is equal to 40 meter above the ground and the efficiency of pump is 30%. How much electric power is consumed by pump? Now efficiency. What is meaning of efficiency? Efficiency means it is always output upon input. Efficiency means it is always output upon input. Okay, yes, it is equation of efficiency, general equation. Okay, efficiency is equal to output upon input. Output upon input. So yes, here if I want to write efficiency, then I can write efficiency eta is equal to, it is output power. Here it is output power divided by, here it is input power. Here it is input power. Okay, now see how to identify this one is input power and this one is output power. Simple question. How to fill tank which is on top of building? Simple. You have to switch on. If you switch on, motor or yes, pump starts, and due to that water rises up. Yes or no? So what is input? Electrical energy, electrical power. What is input? Electrical power. And what is output? Water is going in upward direction. That is function of pump. That electrical energy is converted in potential energy. So yes, here output power is potential energy. That water rises on building. Clear about this? And yes, we have to find this input power. How to write? Efficiency you are given eta is equal to 30%. Efficiency eta you are given, you have 30%. So yes, we can write it is 0.3 because it is 30 divided by 100. So it is 0. Okay. Then how to find this? See, efficiency eta is equal to output power PO upon input power PI. Okay, you have to find PI. Then PI is equal to PO upon. Now what is PO output power? What is output power? Is output power PI is equal to, it is mgh upon T divided by, here it is divided by eta. Okay, so yes, input power PI is equal to, here it is mgh T and here it is eta. Each and every value is given. M is given, G is given, H is given, T is given, and N is also given. Yes, you have to find what is input power. Yes, you have to find what is input power, and again you have to write what is answer of this input power. What is answer of this input power in comment box. Clear about this? So yes students, you have to try how to calculate some questions. Okay, so yes, for today this is it.